good with this? All right, here we go. State whether the product, gentlemen, state whether product AB, so you're multiplying A and B, is defined. If so, give the dimensions of AB. So here we have A and here we have B. This is how you tell whether it's defined. Remember, this is row times columns, correct?
Yeah.
If it's defined, the column of the first matrix is going to be equal to the row in the second matrix. These have to be equal. So, if the column from the first matrix is the same as the row from the second, it is defined and can be multiplied.
And you could flip it around. You could do B. A.
Hold on. Let me explain that. If it is defined, your answer, if it is defined, I don't know why it's so dark today, it's just annoying me. If it is defined, your answer will be 3 by 2 for this one. Okay, if it is defined, your answer will be 3 by 2 for this instance. Would you mind shutting those? That might help. Okay? Yes, Elise.
So is it just like the outside?
Exactly. It's the outside numbers will be what your matrix, your answer is for your matrix. Okay. So question then, is this one defined? Is that defined?
No.
Nope, you can't multiply them. Okay, not defined. You are going to have to be identified on the test whether these things are defined or not. If they're not defined, you can't multiply them. All right, so let's find AB. This is where you need your colors. I'm going to use 4 colors. You can share with your neighbor if you need to.
Yeah.
It's important to remember rows. Gosh, I'm getting annoyed today. There is way too much commotion. Here we go. So, multiply rows by columns. This is why I remembered RC Cola. You guys never heard of RC Cola? You got to come up with something else that help you remember RC, rows by columns. Okay? Whatever you want to remember. First thing I'm going to look at is this defined? Are these two defined? I have a 2 by 2 and a 2 by 2. Is that defined?
Yes.
Yes. And my answer is going to be what size? 2 by 2. Okay, this tells me defined. The outside tell me what my answer is going to be. Got it? Okay, it helps me set up the problem if I know what my answer is going to be. So now what I'm going to do is I got to multiply the rows by the columns, and this is how you do it. So I'm going to do this row, I'm going to use an orange, and I got to multiply it by this. So I'm going to set this up as a very large 2 by 2. In the learning process, it's just going to be big. Next time we won't have to do it so big. And I'm going to say, okay, for this row times this column, I have 2 times 1 plus negative 3 times 3. That's going to be the first element in my 2 by 2 matrix. Look, 2 times 1 plus negative 3 plus 3. Times 3, excuse me. There's a plus in the middle there. All right? Now I got to do that same row by the second column. That same row by the second column. So now I'm going to have 2 times negative 4 plus negative 3 times negative 2. Cool?
So you,
Right.
So you add together the two multiply.
Mm-hmm.
Yeah.
Okay, now I got to do the bottom row by the first column. The bottom row by the first column. So I have 1 times 1 plus 5 times 3. This color thing is really just for the learning. You don't always have to do this. We're going to get it shortened, don't worry, but it's just to learn it. And then the last thing I have to do is the bottom row by the second column. Bottom row by the second column. You know, it gets a little weird looking. So I'm going to do 1 times negative 4 plus 5 times negative 2. Eventually you'll get to the point where you can just do this in your head. Today, you'll be able to do it in your head. Okay, but to set it up. So, my answer then. All I do is I add, do the math, and I'm going to have my AB matrix. So 2 times 1 is 2, plus negative 9 is negative 7. This is the first element here, negative 7. 2 times negative 4 is negative 8, plus 6, negative 2. One plus 8 is 9. Negative 4 plus negative 10 is negative 14. Absorb that for a minute.
Wait, 1 plus 8? Wait, no, that one's wrong.
Did I add it wrong?
It said 1 plus 8.
1
You added
plus,
them.
look what you did.
Yeah, I did that the first time this morning too. Don't ask me why.
Why?
I don't know why. What did I do?
You did 1 plus 8.
Oh yeah, I'd added instead of, see how easy it is to screw up? 16, no you don't. Okay, so that's the first one. Let's do one more. No, I know.
You explained that way down just in the
Okay, so here, I want you to try this exact same thing with this one. Do it on your own real quick. Try it. Exactly what I did here. Okay, this is what you should have. How did it go? Yes, sir. I'm sorry, what?
Never mind. I got it.
Here we go. Use the given matrices and evaluate the expression. So they gave us A, B, and C. So what they want us to do is they want us to multiply A times B minus C. So we have to follow the order of operations. So the first thing we would do is what? B minus C. But what I'm going to do is, since I'm not doing anything with A right now, oh wait, first I'm going to do my dimensions because it might help me determine later whether or not I can do this.
It worked.
It will work. So I'm going to write A over because I'm not doing anything with that right now. 3, -2, 0, 4, -1, 5. I'm just writing A over. That's all I'm doing. This is A.
Wait, how do you know if you can do it with like all? How do you know if you can multiply with all three? You can't.
They're not asking you to do that. Okay.
We're just kind of assuming that we can.
You don't need to.
I did.
Okay? Not too bad. It's a learning process. I was a little thick at first when I was reviewing this. I'm like, what? But the more I did it, the better you get at it. Okay? It's doable. Not too complicated. It's just keeping it organized. All right, this one, yes, we're going to do this one. AB minus AC. So I'm just going to jump right in and I'm going to do AB. First of all, can I do AB? Can I do it? Yes, they are defined. So let's jump right in and do it. Ready? 3 times 2 is what?
6.
6 plus -2. Which is what?
Yes.
It's positive 4. 6 plus -2. Okay, so now I got to do first row times second column. -9 plus 0. -9.
I can do that one.
Now I go to the second row times the first column. 0 times 2 is 0, plus 4 is what? 4. Second row times the second column. 0 plus 0. 0.
I do get 4 in the first one.
For here or here? Which 4?
First one.
This one?
Yeah.
3 times 2 is 6 plus -2.
Oh, okay, I wrote that one.
Okay? And then the last one is -1 times 2 is -2 plus 5, 3. And then -1 times -3 is +3 plus 0, 3. Now for the sake of time, I'm just going to tell you what AC is. 14, 7, -16, -8, -22, -11. And then when you subtract them, you get this: -10, -16, 20, 8, 25, and 14. Of a chain of entertainment stores. I think there's some stuff missing from this picture, actually. I'm going to say store 1, store 2, store 3. This represents CDs. This represents DVDs. Do y'all remember what VHS is? Do you? And games. These are games, okay? So, this represents an inventory matrix. It's just showing what they have in the store. If CDs cost $15 and DVDs cost $20 and VHSs cost $18 and games cost $30, the cost of each item is represented by the matrix. Okay, so you have to write a cost matrix. Now, ladies and gentlemen, if I'm going to use these two matrices together, I don't want to write my cost matrix this way, because then I can't multiply them, can I? Because this is a 3 by 4, and this is a 4 by 1, so I could multiply them because they're defined. If I wrote it 1 by 4, I couldn't multiply them. Does that make sense? When you're asked to set up an inventory and a cost matrix, make sure you set them up so you can multiply them together, so they're defined. Okay, so we're going to multiply this times this. Okay? Can we do it? Yes, we can. We have a 3 by 4, and we have a 4 by 1. Yes, we can multiply that. What's our answer going to be? How big? How big is our dimensions of our answer? 3 by 1. Okay? 3, see, this shows us that it's defined. The dimensions of our answer are going to be 3 by 1. Okay? Okay? Now,